Good afternoon. Thank you so much for coming to this deep dive session. I love technology, and many of you do too. But what is the goal? Sometimes we are so excited about the technology that we forget what the purpose is. Is the goal to pursue technology just for the sake of it? As mentioned during the plenary, I believe that the goal should always be about helping people. And that is what we mean by human-centered. It means that we work hard for the purpose of helping others. In fact, this is the philosophy and spirit of Toyota, stretching back to its founder, Sakichi Toyota. So let me tell you more about Woven Planet's technology and products that focus on amplifying human potential. Our automated driving and advanced safety systems start with the sensors. We combine radar, cameras, and LiDAR and fuse that information together in a rich package of computing and sensing data that creates a 360-degree omnidirectional view of the traffic environment around a vehicle. The core elements of technology for all automatic vehicles are the 3 P's of perception, prediction, and planning. Perception involves attempting to calculate and process what the vehicle sees in the surrounding traffic environment. But it's not enough to simply perceive the current positions of surrounding traffic. The vehicle must also perform prediction. That means estimating and predicting the future movement of traffic around the vehicle. Accurate prediction allows the vehicle to safely plan its motion in the next instant. This cycle of perception, prediction, and planning is constantly repeated as the vehicle moves through the world. In 2021, we launched our Teammate Advanced Drive product into the market, first on the Mirai second-generation zero-emissions fuel cell electric vehicle. The Advanced Drive provides hands-off automated driving for highways with automated lane change and assistive comfort driving for you when you take long trips. We also launched our Lexus Teammate or Lexus Advanced Drive on the LS500 Hybrid. This includes the same kinds of technology to provide the hands-free driving ramp-to-ramp on a highway, but with the comfort and class of a Lexus vehicle that our customers expect. Here's an example of what the computer actually sees. This is LiDAR data point clouds rendered in real time, showing overlaid automated map generated that calculates the semantics and geometry of the traffic environment. We use this sensing data in order to train our machine learning systems. And when we think about machine learning, one of the important points is that data is absolutely critical. Most of the state-of-the-art machine learning algorithms are open source, meaning that you could download them today. But you wouldn't be able to do much with them without data. And it isn't just quantity of data, it's actually quality and diversity of data that's important. That's why at Toyota, we're trying to fully leverage the scale of our products and services around the different regions of the world to build highest quality, diverse models of traffic so that we are able to perceive and predict at scale with great quality and safety. Because when it comes down to it, we need to be able to test in parallel all of these situations. It isn't scalable to test them physically. Instead, we leverage cloud-based simulation and virtualization testing. That means our engineers can make changes to software with speed and scale, and then test thousands of these corner cases in parallel, and within 5 minutes get back a report saying that this change improved performance and safety and quality. Because really, it's about producing excellent software. Together with excellent hardware, we can deliver to customers high-quality, safe products. Toyota is known for the Toyota Production System, and many of you may know this system as TPS. TPS is famous around the world as the best way to deliver high-quality hardware and mechanical systems with reliability and quality at scale with affordability and repeatability. And that's really what we're attempting to do at Woven Planet for software, meaning we create processes and tools for allowing our engineers to deliver safe, high-quality software to our customers that we install on our high-quality hardware to deliver those safe, high-quality products. When we think about software, many of us are focused on the onboard software. This is the software that runs on the car. But actually, that's not all that you need. We also need software to train our machine learning systems, to label the data, to build the neural networks, to optimize them. We also need developer tools to manage all of the source code, create unit tests and regression tests, to test for quality. We also need simulation tools to validate and test the real-life scenarios in simulated worlds before testing them on the real car. But we need to be able to deploy that software and also to create data management and logs so that we can then feed that information back into our training. And of course, we need to have excellent automated maps to represent the geometry and semantics of the digital traffic environment for our developers. If you put all of these things together, about 90% of the software you need is offboard, meaning it doesn't run on the car. But you need that offboard software in order to create high-quality, defect-free onboard software. At Woven Planet, together with our partners at Toyota, we're building that system. When we think about what we can do when we have those high-quality new mobility products, it opens up possibilities for our cities. Our cities around the world are being faced with lots of common challenges of safety, traffic, pollution, and sustainability. And many cities have adopted different solutions, mostly centered around traditional cars. But right now, our vehicular roads are quite cluttered. Imagine if we were able to separate the mobility into different types, like higher speed vehicular mobility on one thoroughfare, and then intermediate mobility with personal mobility or bicycles, and then finally pedestrian mobility for pedestrian speeds. We weave these modes of transportation together, and you get a vision for Toyota's Woven City. Woven City is being built on the former site of the Toyota Motor East Japan, or TMEJ, factory. And it's a vision for the future fabric of life, testing new mobility products and services digitally, meaning that we can use intelligent vehicle software and smart infrastructure together with sustainability to create a true carbon-free vision of our future cities and test them at scale. We want to be able to deliver this to customers, and I'm excited to give you an update on the actual progress. So we started construction in early 2020, and over the past several months, we've been able to dig not only the foundation of the city, but also to start pouring the foundations of the actual buildings, which happened November 2022. I'm really excited to be able to see Woven City when it is fully realized. But we don't actually have to wait until it's fully realized because we are creating a digital twin, which I'll tell you about in a minute. But the goal of Woven City is really to understand how we can expand mobility and engage society and support our community with real customers, with real mobility needs and real mobility products and services in the real world. Digital technology to accelerate our development is being fully leveraged much the same way that computer-aided design tools have accelerated our ability to develop powertrain and chassis and engine design without having to build physical mocks every time, which can be expensive and cumbersome. Instead, we can virtually iterate with digital versions until we can create the highest quality results. Today, we are creating a digital twin of the Woven City project. That means you can experience the next generation of future mobility digitally today using VR and graphics and simulation technology. Putting everything together, you can see a virtual version of Phase 1. This allows us to answer interesting questions such as, if I wanted to have a package delivery system, how many robots would I need to deliver packages for 1,000 residents at scale with an average estimated delivery latency time of 10 minutes? This is something that we would not be able to answer without the power of digital twin technology. In some ways, this is a kind of digital TPS, allowing us to explore many different possibilities in parallel and test them all at scale. I'm really excited about testing these new kinds of mobility and creating and envisioning the future fabric of life for our smart cities of the future. The true goal is really to unlock the full potential of people and amplify their abilities. Amplifying their capabilities really means building technology and services that are clearly centered around people and our planet. Because health and happiness for people in our planet is something that will benefit all of us. I'm really optimistic and excited about the future of this technology to not only expand mobility, to enhance our communities, but also bring us together with happiness and safety. Thank you very much for your attention.